proposal to expand arc fault circuit interrupter protection in dwellings to include all 120 volts, 15 amps, and 20 amps branch circuits has raised concerns among some electrical professionals. Critics argue that the proposal benefits arc fault circuit interrupter manufacturers, who will potentially see increased profits. They also point out that arc fault circuit interrupter technology is still immature and cannot reliably detect all fire-causing arcs. Arc fault circuit interrupter devices are microprocessor-based, relying on computer code to identify arc signatures. Each manufacturer has its own code, which can vary in effectiveness. Nuisance tripping caused by non-arc activity remains an issue with some arc fault circuit interrupter devices. Underwriters Laboratories testing ensures that arc fault circuit interrupter devices operate during specific simulated arcs, but it does not test for nuisance tripping. Critics suggest that independent testing of arc fault circuit interrupter breakers with various appliances is necessary to assess their maturity and reliability. If arc fault circuit interrupter protection is mandated without ensuring its effectiveness, it could create a false sense of security among homeowners. While arc fault circuit interrupter devices can detect some arc faults, they may not be able to prevent all electrical fires. Electrical professionals and consumer advocates call for further investigation and testing of arc fault circuit interrupter technology before mandating its widespread use. They suggest that Consumer Reports or other independent organizations conduct such testing to determine if arc fault circuit interrupter technology has matured sufficiently to warrant expansion. In conclusion, while arc fault circuit interrupter protection can provide some electrical safety benefits, concerns regarding its effectiveness, reliability, and potential false sense of security should be addressed before mandating its expansion. Further independent testing and research are necessary to ensure that arc fault circuit interrupter technology is mature enough to justify its widespread use in dwellings. This has led to discussions about the need for more comprehensive testing standards that include not only the detection of actual arc faults but also the prevention of nuisance trips caused by common household appliances and lighting systems. The concern is that if arc fault circuit interrupters trip too frequently under normal operating conditions, users may become desensitized to their importance or even bypass them, thereby negating the safety benefits they are intended to provide. The role of underwriters laboratories in certifying arc fault circuit interrupters is also being scrutinized. While underwriters laboratories certification ensures that the devices meet certain minimum safety standards, some argue that these standards are not rigorous enough to address the complexities of real-world electrical systems. The testing protocols may not adequately simulate the diverse range of appliances and electrical loads found in modern homes, which can lead to discrepancies between laboratory performance and actual field performance. There is a growing call for underwriters laboratories to update its testing procedures to include a wider variety of operating conditions and potential sources of nuisance tripping. Independent testing organizations such as Consumer Reports could play a crucial role in evaluating the performance of arc fault circuit interrupters. By conducting their own tests using a range of appliances and lighting systems, these organizations can provide consumers with valuable information about the reliability and effectiveness of different arc fault circuit interrupter models. This information can help consumers make informed decisions about which arc fault circuit interrupters to install in their homes, ensuring that they are getting the best possible protection against electrical fires. In addition to independent testing, there is also a need for more research into the causes of nuisance tripping in arc fault circuit interrupters. This research could help manufacturers develop more sophisticated algorithms for detecting arc faults, reducing the likelihood of false positives. It could also lead to the development of new arc fault circuit interrupter designs that are less susceptible to interference from other electrical devices. The goal is to create arc fault circuit interrupters that are both highly effective at detecting arc faults and highly resistant to nuisance tripping, providing homeowners with reliable protection against electrical fires without unnecessary disruptions. The debate over arc fault circuit interrupter expansion also raises broader questions about the role of technology in electrical safety. While arc fault circuit interrupters can provide an additional layer of protection against electrical fires, They are not a substitute for sound electrical practices. Proper wiring, regular inspections, and the use of qualified electricians are all essential for maintaining a safe electrical system. Homeowners should also be educated about the limitations of arc fault circuit interrupters and the importance of following basic electrical safety guidelines. Ultimately, a comprehensive approach to electrical safety that combines technology with education and responsible practices is the most effective way to prevent electrical fires and protect homes and families. The expansion of arc fault circuit interrupter requirements in the National Electrical Code reflects a growing emphasis on electrical safety in residential buildings. However, it also highlights the challenges of implementing new technologies and the importance of ensuring that these technologies are both effective and reliable. As arc fault circuit interrupter technology continues to evolve, it is essential to address the concerns raised by electrical professionals and consumer advocates to ensure that arc fault circuit interrupters provide the intended safety benefits without creating unnecessary burdens for homeowners. This requires ongoing research, independent testing, and a commitment to continuous improvement in arc fault circuit interrupter design and performance. Moreover, the discussion surrounding arc fault circuit interrupters underscores the need for a collaborative approach to electrical safety. Manufacturers, testing organizations, code developers, and electrical professionals must work together to develop and implement standards that protect consumers while also promoting innovation and technological advancement. By fostering open communication and sharing knowledge, the electrical industry can ensure that new technologies like arc fault circuit interrupters are used effectively to enhance electrical safety and prevent electrical fires. Furthermore, the experience with arc fault circuit interrupters offers valuable lessons for the implementation of other emerging technologies in the electrical field. As new devices and systems are developed, it is crucial to carefully evaluate their potential benefits and risks, to conduct thorough testing, and to address any concerns raised by stakeholders. This proactive approach can help to ensure that new technologies are deployed safely and effectively, maximizing their positive impact on the electrical industry and the public. In addition to the technical aspects of arc fault circuit interrupters, there are also economic considerations to be taken into account. The cost of arc fault circuit interrupters can be a significant factor for homeowners, particularly those on limited budgets. The expanded arc fault circuit interrupter requirements in the National Electrical Code could increase the cost of new construction and renovations, potentially making housing less affordable. It is important to consider these economic implications when evaluating the benefits and costs of arc fault circuit interrupters. Policymakers should also explore ways to make arc fault circuit interrupters more affordable, such as offering tax credits or subsidies to homeowners who install them. By reducing the financial burden of arc fault circuit interrupter installation, it may be possible to increase their adoption rate and improve electrical safety for a larger number of homes. The long-term economic benefits of arc fault circuit interrupters should also be considered. While the initial cost of arc fault circuit interrupters may be significant, they can potentially save homeowners money in the long run by preventing electrical fires. Electrical fires can cause extensive damage to homes and property, leading to costly repairs and replacements. They can also result in injuries and even fatalities, which can have devastating economic consequences. By reducing the risk of electrical fires, arc fault circuit interrupters can help to protect homeowners from these financial burdens and personal tragedies. Furthermore, the widespread adoption of arc fault circuit interrupters could have broader economic benefits. By reducing the number of electrical fires, arc fault circuit interrupters can help to reduce the burden on fire departments and emergency services. They can also help to lower insurance premiums for homeowners. These savings could free up resources for other important priorities such as education, healthcare, and infrastructure. In conclusion, the decision to expand arc fault circuit interrupter requirements in the National Electrical Code is a complex one with both technical and economic considerations. While arc fault circuit interrupters have the potential to improve electrical safety and prevent electrical fires, it is important to address the concerns raised by electrical professionals and consumer advocates regarding their effectiveness and reliability. It is also important to consider the economic implications of arc fault circuit interrupter adoption and to explore ways to make them more affordable for homeowners. By carefully weighing the benefits and costs of arc fault circuit interrupters, policymakers can make informed decisions that promote electrical safety and protect the public interest. The evolution of arc fault circuit interrupter technology has been a continuous process of improvement and refinement. Early arc fault circuit interrupters were prone to nuisance tripping, which led to frustration and skepticism among some users. However, manufacturers have made significant strides in recent years to improve the performance and reliability of arc fault circuit interrupters. New arc fault circuit interrupters are equipped with more sophisticated algorithms that are better able to distinguish between actual arc faults and normal electrical activity. They also incorporate features that help to reduce the likelihood of nuisance tripping, such as filters that block out high-frequency noise. As a result, modern arc fault circuit interrupters are much more reliable and effective than their predecessors. The ongoing development of arc fault circuit interrupter technology is being driven by a combination of factors, including regulatory requirements, market demand, and technological innovation. The National Electrical Code has played a key role in promoting the adoption of arc fault circuit interrupters by mandating their use in certain applications. This has created a market for arc fault circuit interrupters and has incentivized manufacturers to invest in research and development. Market demand for arc fault circuit interrupters is also being driven by growing awareness among consumers of the dangers of electrical fires. As more people learn about the potential risks of electrical fires, they are more likely to take steps to protect their homes and families, including installing arc fault circuit interrupters. Technological innovation is also playing a key role in the development of arc fault circuit interrupter technology. New materials, manufacturing processes, and electronic components are enabling manufacturers to create arc fault circuit interrupters that are smaller, more efficient, and more reliable. The future of arc fault circuit interrupter technology is likely to be characterized by continued innovation and improvement. Manufacturers are working on new arc fault circuit interrupter designs that are even more effective at detecting arc faults and preventing nuisance tripping. They are also exploring new applications for arc fault circuit interrupters, such as in electric vehicles and renewable energy systems. As arc fault circuit interrupter technology continues to evolve, it is important to stay informed about the latest developments and to choose arc fault circuit interrupters that meet your specific needs and requirements. Consult with a qualified electrician to determine the best arc fault circuit interrupters for your home or business. In addition to arc fault circuit interrupters, there are other electrical safety devices and practices that can help to protect your home and family from electrical fires. Ground fault circuit interrupters are designed to protect against electric shock by detecting ground faults and interrupting the flow of electricity. Surge protectors are designed to protect electronic equipment from damage caused by power surges. Smoke detectors are designed to detect smoke and provide an early warning of a fire. Regular electrical inspections can help to identify potential hazards and ensure that your electrical system is safe and up to code. By combining arc fault circuit interrupters with other electrical safety devices and practices, you can create a comprehensive safety plan that protects your home and family from the dangers of electrical fires. Remember, electrical safety is an ongoing process, not a one-time event. It is important to stay informed about the latest electrical safety guidelines and to take steps to protect your home and family from electrical hazards.